A car moves from rest, accelerates to attain a velocity of 15 meters per second, move from rest. That means at this stage, initial velocity was 0, move from rest. Final velocity at this time, that is within these 6 meters of journey, that's the velocity is 15 meters per second. And he said that this 15 meters per second, he was able to achieve it in 120 seconds. So if he did it in 120 seconds, that means acceleration whenever is equal to 15 divided by 120 seconds, 15 meters per second, that's the velocity. It was from 0 to 15 meters per second. And that is 15 meters divided by, if you remember that acceleration is changing velocity over time. Look at it, 15 minus 0, 15 divided by time of 120. For time of 120 seconds, which gave me 0.125 meters per second. Gave 0.125 meters per second. That is square. That is the acceleration within this period. And he said that this vehicle traveled at this velocity for 6 meters. For this 6 minutes. It travels at this velocity for 6 minutes. So time he used to do this one, 6 minutes, which is equal to 360 seconds. That is 6 times 60 seconds. 1 minute is 60 seconds times 6. So he gave you 360 seconds. That is what he used to. You now say, the person now go on to say, then brought to rest. After this, the vehicle was brought to rest with a uniform retardation. That's deceleration. With a uniform retardation in 4 minutes. The period of coming down was 4 minutes. That's 4 minutes. 4 minutes, which is equal to 240 seconds. 4 times 60 seconds. They used to come down. They now say, what is the total distance? What is the total distance traveled? What is the total distance traveled in the car? That is the total distance traveled. That's what the question is asking. What is the total distance traveled by the car? So we are going to get the distance traveled in 6 minutes. Then get the remaining distance traveled in 4 minutes to stop. That's all. So let's get the first one, the total distance traveled in 6 minutes. We can use the second equation, in which, the second equation, this one, in which ut will be 0 because it started from rest. It started from rest. So since it started from rest, the initial velocity will be 0. So that means the s in 6 minutes will be times the acceleration. The acceleration was 0.125 times time. Time was 6 minutes, which is 360 seconds square. 360 seconds square. That is what it did in 6 minutes. The distance it traveled in 6 minutes, which gave me 8,100 meters. That's what it traveled in 6 minutes. After traveling that distance in 6 minutes, it now starts to decelerate. In the deceleration, where it now starts to decelerate. To get the deceleration, that happened, at the time it decelerates to stop, final velocity will be 0. So if we use the first equation to get the deceleration, we have 0, it stopped. With the initial velocity at that time, which is initial velocity was 15. Initial velocity was 15 to get the deceleration. So 15 minus, because it was a deceleration, that's why this will have a plus, minus the acceleration. 15 minus the acceleration times time. So, and this acceleration is what we are looking for. Times time. Time was 240 in 40 minutes times A. So from there you get A, which is a deceleration. It will be 15 over 240. 15 over 240, which is 0.062. 15 over 240. 0.062 meters per second square. That is the deceleration. That deceleration in 4 minutes. So to now get the distance traveled in 4 minutes, we have gotten the distance traveled in 6 minutes. We can also still use the second equation, in which we have that initial velocity was 15 and the time was 240. The time in question was 240. So we have S is equal to, that is this, 15 times 240 minus, because it was decelerating, half times the acceleration of 0.6062. So times half times 0. That deceleration 0.62, then times time of 240 squared. That's the distance traveled in 4, when it was trying to stop, in 4 minutes. Distance traveled in 4 minutes when it was trying to stop. I got it to be 1814.4 meters, which can be what 1.8181 kilometers. So that's the distance it traveled to stop. So the total distance traveled by the vehicle. Both the one is traveled when it was accelerating in 6 minutes, and the one it traveled when it was decelerating in 4 minutes. That's this plus this, which is 8100 plus 1814.4 meters. The total distance traveled is 9914.4 meters, which is equal to 9.9 kilometers. That distance traveled by the vehicle, both in accelerating and decelerating. So that's that. The question says, let me read the question again. The question says that a car moves from rest. A car that moves from rest accelerates to attain a velocity of 15 meters per second in 120 seconds. A car that moves from rest accelerates to attain a velocity of 15 meters per second in 120 seconds. It traveled at this velocity for 6 minutes. It traveled at this velocity for 6 minutes and then brought to rest with a uniform retardation in 4 minutes. What is the total distance traveled by the car? That's the question. A car travel from rest accelerates and attain a velocity of 15 meters per second in 120 seconds. It traveled at this velocity for 6 minutes and then was brought to rest with a uniform retardation in 4 minutes. What is the total distance traveled? So we got the distance traveled in 6 minutes and distance traveled in 4 minutes, and add the two. You got the total distance traveled. That's the answer. Thank you very much.